So there are several types of problems where all you have to do is find the maximum or the minimum, depending on the way that the problem is set up. So here's one. This one's going to seem kind of artificial because it kind of is, because nobody stays awake at night trying to figure this out. Among all numbers, whose difference is 10, find the pair whose product is as small as possible. And what is the minimum product? So what we need to do is we need to set up some equations to represent this situation. First thing I always like to set up is the equation for the thing I'm trying to maximize or minimize. So what am I trying to maximize or minimize here? I'm trying to maximize or minimize the product of the two numbers, right? So let's say one number is x and one number is y. What would the product look like? Not just y. If the numbers are x and y, then what does product mean? Huh? Yeah, it's the answer to a multiplication problem. So basically, if I take the two numbers and multiply them together, I get the product. Now, what else do I know about these numbers? How would I write that as an equation? Okay, so specifically, so x minus y equals 10. Now, as it sits right now, this product expression has two variables in it. That's kind of hard to find the maximum or actually the minimum there. But what I can do is I can adjust this other equation here. I can solve it for one of the variables, and then I can substitute and see what happens. Which variable would you like to solve for in this equation right here? X. So pretty clearly you add y to both sides and you get x equals y plus 10. So then what I'm going to do is I'm going to take that and I'm going to plug it in here. So P is equal to y plus 10 times y. What can I do next? Distribute. Y squared plus 10y. If I were to graph this equation, what would the graph look like? Yeah, it's a parabola that opens upward. Therefore, it would have a minimum value, which is what we're looking for, right? And the minimum value would occur where? At the vertex. So basically, at this point, all you've got to do is find the vertex. So I'm going to use y this time because y is my variable, but I'm still going to use this formula negative b over 2a. So that would be negative 10 over 2 times 1, which is negative 5. Notice that it's not super hard to get the other number. All I have to do is take that negative 5 and plug it into this. So, x would be negative 5 plus 10, which is 5. So the two numbers are 5 and negative 5. And to get the minimum product, all you have to do is multiply them together, right? So the product, or the minimum product, if you will, would be negative 25. Now, I want you to pay extra close attention to this example. I wasn't able to get any homework problems over it, but it's on your test. Therefore, you need to learn how to do it. So on guard. I'm just kidding, it's not that kind of offensive. This is like we're trying to erect a fence. You know, like put up a fence. So, as a result, let's say we have the following scenario. We have 100 yards of fence. We need to make an area like that, where not only do you have a rectangular fence, but you've got a fence dividing it down the center. What is the maximum area and what are the dimensions? This is probably the most missed question amongst any test in college algebra. So let's understand how to do it. First off, what are we trying to maximize? The area. How would you compute the area of that thing? Length times width. So area is equal to length times width. And it might help if we labeled it. So let's label that length and that width. Just keep in mind that's purely arbitrary. You could label it whatever way you want. You could make the other side length and width, you know, but let's just say I'll label it like that. Now, as it sits right now, length times width, I really can't figure out how to maximize that. But what I can do is I can set up another equation that involves the amount of fence. So I've got 100 yards of fence, right? So I need to figure out how that's going to be distributed amongst the lengths and the widths. How many lengths would I need to make out of this fence? 2, right? 2 lengths. How many widths? 3. Because look, you've got the 2 on the outside, plus the fence that's got to go down the middle. Yeah, because if you didn't have that fence that goes down the middle, you just make it into a square, because the square maximizes the area of a rectangle if all the sides are the same. But it won't be a square this time around because the fence goes down the middle. So similar to the last problem, what we've got to do is we've got to take this equation here and solve it for one of the variables. Which variable would you like to solve for? L. Oh, bloody L. Anyway. (2L equals negative 3W plus 100, right? And then you divide everything by 2. L equals negative 3/2 W plus 50. And we're going to take that, we're going to plug it into this. So my area is equal to negative 3/2 W plus 50 times W. Just like before, we distribute negative 3/2 W squared plus 50W. And if you notice, just like the discussion we had last time, that graph would be a parabola. And which way would it open? It would open downward. And therefore, at the vertex, you would have a maximum. And that's the point we're looking for. So, we would need to find the vertex. Negative b over 2a. So this would be negative 50 over 2 times negative 3/2. Notice that 2 divided by 2 is 1. Negative divided by negative is positive. So the width is 50 over 3. Now that's perfectly good mathematically, but in the real world, we probably wouldn't run around saying, I've got to make this 50/3 yards. So that happens to be 16 2/3. So that'd be 16 yards and 2 feet. But for the context of the problem, since we are in a math class, we can go ahead and leave it as 50 over 3 yards. What else would I need to solve the problem? The length. Well, don't I have this sitting right here? So, the length is equal to negative 3/2 times 50 over 3 plus 50. First of all, the 3's cancel. 50 divided by 2 is 25, and it's negative. So negative 25 plus 50 is 25. So I've got the width, I've got the length, but to answer the question completely, see, we answered the dimensions part, I need the max area. But once you've got the dimensions, that's fairly simple. How would you get that?